this one. It's a rough, the surface is rough. What conditions will arise here? The frictional force acting on the ring is asking. Shall we solve this, or shall we directly say that it is having some value? I am asking, since you know so many things, will you go for really solving, or you have some information, better to use that information? The moment I apply force, no doubt. So what about here friction? Friction at the disk, in what direction it will act? I think these are primary questions we'll ask ourselves. In what, sir, how to decide the friction at this point? Towards right or towards left? No rolling, so rolling will take place. The frictional force acting on the ring, this one. So definitely the friction is sufficient for pure rolling, we'll put it. And that's basic idea. So friction should be forward or backward. It should be backward. If you put forward, what problem will arise, we'll see. If you put forward, then how the alpha angular acceleration will be counterclockwise, then slipping will occur here. Friction sufficient for pure rolling. I'll add that comment. Friction sufficient for pure rolling. Okay, now I think this will be not possible. The friction should be here. Let me call F1. The tension, the string, let it be T. Then you go for the ring. If a force acts at highest point, what will be the tension or any external force? The friction acting at the surface will be 0, because the threshold point for the ring will be at highest point. For a disk will be at R/2. Here, sir, I don't know all that. It's a memory based. Okay, you assume friction, solve the problem, then apply all the things. So let acceleration of this be A1, angular acceleration of this be alpha1, acceleration of this be A2, angular acceleration of this be alpha2. Solve it, you'll get F2 0. Or else, in a very simplified way, what is that? If you apply force for the ring at highest point, because for the ring, the threshold point will be highest point. When you apply force at the threshold point, the friction should be, rolling friction should be 0. Or how to solve this? The equations will be of this kind. F minus T minus F1 equal to MA. Then F1 R minus TR equal to this will be MR square by 2 alpha 1. A1 equal to R alpha 1. Then condition for no slipping, A1 equal to R alpha 1. I'm bothered about these points. The string should be taut. So during motion, what is the condition? This should be taut and inextensible. So therefore, primarily what I should write? Acceleration of point P1 along x-axis must be 0. Acceleration of point P along x-axis. The direction of friction, it should not be forward. If it is forward, alpha will come like this. Then slipping occurs here. So the friction on the disc should be backward. On the ring, if you apply force at threshold point, the friction acting will be 0. On any rigid body, if you apply force at threshold point, the threshold point for the ring will be at highest point. For a disc will be R/2. Hope if you can remember, if all of you can remember that one. So I am very sure that answer F2 will be 0. That I'll show it mathematically here. So AP1x should be equal to A1 plus R alpha. AP2x should be equal to A2 plus R alpha 2. I think this is a primary equation. For the ring, we'll write the equation T plus F2 equal to MA2. Then T into R, F2 into R equal to MR square alpha 2. Then A2 should be equal to R alpha 2. Solving all this, you will end up for sure, F2 should be 0. What you should do here is like A1 substitute here, R alpha 1 substitute here, A2 substitute here, or A2 equal to R alpha 2. That you can write it 2A1 equal to or A1 equal to A2. Solving this will get expression for tension and friction. But sir, like look at the unknowns. F1, F2. So many unknowns are there. Can we really manage this? So this T gets eliminated. It's very simple. A1 equal to A2. Add up these two. F1 and F2 will come into picture. Then here also you have here, no? So actually this T will get eliminated. F1, F2 is things where you'll get that one. F1 will be non-zero, F2 should be 0. So rather than this, I suggest you must take help of what, like if you apply force at threshold point for a rigid body, the rolling friction will be 0. Directly you can write F2 0. I think the intention of the question was to answer directly rather than solving in this way. I'll scroll down. This will be, I think, have a time. Let me check it.